In this video, we're going to talk about phase diagrams. Now, what I want you to keep in mind with phase diagrams is conceptually they're very easy to read, but there is a lot of detail that gets wrapped up in phase diagrams. A lot of things we typically gloss over that I want you to be aware of. Now, a big thing to keep in mind with phase diagrams, at the 152 level, you are dealing with what are called PT phase diagrams, pressure versus temperature. There are actually multiple types of phase diagrams. There are VT, volume versus temperature, PV phase diagrams, where it's pressure versus volume. And they have a lot of information that don't necessarily appear in the PT diagrams. So if you're looking up Wikipedia articles, you're looking up information on this, and you said, oh, give me a phase diagram, you probably notice that there's a lot more out there. Again, we only focus on the PT diagrams. So what does the PT diagram tell you? It tells you that given a pressure and given a temperature, what phase should you expect? Now, at 151, you probably were made aware of three basic phases: solid, liquid, and gas. Solid, fixed positions, things don't flow. Liquid, you have a lot of intermolecular interactions. Things flow, they have a definite volume, but they definitely don't have a definite shape. And the gas phase is one where you don't have a definite volume, you don't have a definite shape, and the particles are so far away from each other and they're moving so fast they don't interact. Well, there's actually a fourth phase. And the fourth phase is what's called the supercritical phase. Now, the supercritical phase consists of solid and liquids dissolved in each other. Now, this is kind of a weird thing to say, and I might try to post a link so you can see the video of when CO2 goes supercritical. But basically what happens above what's called the critical temperature, TC, and above the critical pressure, PC, the pressure is so high that the gas acts like a liquid. The intermolecular forces are so strong they actually act fluid-like. But the temperature is so high that these interactions are still pretty weak, so it acts like both a gas and a liquid. In reality, what you have are the gas and liquid phases together, but they're so similar in density and so similar in properties you can't actually see the two of them moving separately. So, first major point on this phase diagram is what's called the critical point, or CP. The critical point is where you have the temperature, critical temperature, and the critical pressure. And above this temperature and above this pressure, you have a supercritical fluid. Another important point here is what's called the triple point. Now, at the triple point, we have solid, liquid, and gas all existing in equilibrium. Now, this doesn't mean that you just have them, okay? You can have ice and water, and you can have that at room temperature. That's not an equilibrium, because you do have water vapor, you do have water, you do have ice, but the environment's so warm that you just haven't seen them getting in equilibrium. It hasn't warmed up enough. For you to truly be at the triple point, what you have to have are solid, liquid, and gas phases all existing and exchanging atoms with each other. Now, each of these lines represent what's called a phase change. So if we're looking at a line, the phase change we see is the switch from one phase to the next. So if we're moving at constant pressure along this line, let's say we start here and work our way across. As we cross this first line, we have the solid converting to liquid, so we have melting. As we cross this line here, we have liquid going to solid, so we have evaporation. So when we look at phase diagrams, if we have a starting temperature to pressure and we know where we're going to in terms of temperature pressure, we can describe the path that we go along. So when you are asked problems about how, well, if you're given a given pressure and temperature and you move to a different pressure and temperature, what happens? These are the things you need to describe. What phases are you crossing through? What phase changes are you seeing? Are you seeing melting or freezing? Are you seeing evaporation or condensation? Are you seeing subliming? These are the things you need to point out. Now, the other thing to keep in mind with phase diagrams, and we'll go about this in the next video, this line here between the phase, the solid phase, and the gas phase will always slope upwards. And the line between the liquid and the gas phase will always slope upwards. However, the line between the solid and the liquid may not. Occasionally you will see this line going up, and occasionally you'll see it going down. And we're going to go through the next video where this actually comes from. But this is your gist on phase diagrams. For a phase diagram, it's going to show you the phases based on temperatures and pressures, and you should be able to tell me based on where you're starting at and where you're going to what phase changes you're starting to see.